Okay, so let's see the next question, which is of 2 mark. It came in GATE 2020. A stream with a flow rate of 5 meter cube per second is having an ultimate BOD of 30 grams per liter. A wastewater discharge of 20 meter cube per second is having BOD of 500 milligrams per liter. Joins the stream at a location and instantly gets mixed up completely. Cross-sectional area of the stream is this much, remains constant. BOD exertion rate constant is 0.3 per day. BOD in milligram per liter, round off to the decimal place, remaining at 3 kilometer downstream for the mixing location. So we need to calculate the BOD that at somewhere the water is mixed with the river water. This BOD water, sewage water is mixed with river water. Now we have to just calculate what will be the BOD after 3 kilometers of that place. Okay, so let's start. The things which are given to us is discharge of the river is 5 meter cube per second, and we can say the BOD of river is 30. This is a mistake, it should be 30 milligram. So 30 milligram per liter, and the exertion rate constant is given 0.3 per day. So okay, this is ultimate BOD. So BOD ultimate. See, ultimate BOD will be the same, right? So see, if I want to calculate that ultimate BOD of the 5 days BOD is also given of wastewater discharge. So for wastewater, if I want to calculate what was the ultimate BOD, so for waste water, your 5 days BOD 5 is equal to ultimate BOD 1 minus e to the power minus kt. So ultimate BOD comes out to be BOD 5, which is 500, divided by 1 minus e to the power minus k, which is 0.3, and t is 5. So after calculating this comes out to be 643.61 milligram per liter. So I got the ultimate BOD of wastewater. Ultimate BOD of river is 30 milligram per liter, and ultimate BOD of wastewater comes out to be 643.61. Now if I want to calculate the ultimate BOD of mix, I can easily calculate that. It will be BOD, ultimate BOD of river I can say river into discharge of river plus ultimate BOD of sewage wastewater plus into discharge of wastewater divided by QR plus Q wastewater. So if I put the things, discharge of the river is 5 meter cube per second, 5 into ultimate BOD is 30, and for river for the wastewater the discharge is 0.2 and the BOD is 643.61, and the total discharge is 5 plus 0.2. So after calculating this, we got the BOD of the mix is 53.6 milligram per liter. BOD ultimate of mix. What do they want us to do? They want us to know that After 3 kilometers, what will be the mixing, what will be the DO present there? Okay, so see, we have discharge. Discharge is what? Volume upon time. And one thing we have, that velocity is nothing but, velocity is your distance upon time. So if I want to calculate from here what is the time taken in traveling the distance, that will be distance upon velocity. Okay, can I calculate velocity? So velocity is nothing but total discharge upon area. This is nothing but velocity into area, right? So from here I can say that discharge is given. Discharge is 5, total discharge, right? The 5.02, that is total discharge, divided by area, that is 40. So the velocity comes out to be 0.13 meter per second. Okay, now I got the velocity. Can I get the time? Yes, time is nothing but distance. How much distance? 3000 meters we can say, or 3 kilometers, and the velocity is 0.13. so can I get the time? Oh yes, so time will be this much second. I want it into days, so 0.267 days. Okay, now they want what is the BOD remaining. BOD remaining, so BOD remaining is nothing but BOD at any time t, that is L naught e to the power minus kt. L naught is ultimate BOD of the mix, 53.6 into e to the power minus 0.3, and time is 0.267. So the BOD remaining comes out to be 49.5 milligram per liter. This is the final answer. 49.5 in milligram per liter. So after 3 kilometers of the run, it will be 49.5. Okay, let's move on to the next question, which is question number 5, came in GATE 2017. So one question came in 2020, and then last was in 2017, and then 2014. So this chapter we should know about this chapter, or let's move on. Next is two wastewater streams A and B having an identical ultimate BOD are getting mixed to form stream C. That means there are two rivers, right? They are getting mixed to form C. So see, there is river A and there is river B. They both are mixing and forming C. Temperature of the stream A is 20 degrees Celsius. So the temperature is 20 degrees Celsius. At stream C, the temperature is 10 degrees Celsius. Okay. 5 days BOD of the stream A at 20 degrees Celsius, BOD 5 is 50 milligrams per liter. BOD rate constant base 10 at 20 degrees Celsius is, so the value of K is 0.115. Base we will use as 10. Temperature coefficient is given 1.135. Okay, this is BOD at 20 degrees Celsius. Now 5 days BOD of the stream C calculated at 10 degrees Celsius is, okay, let's start. Okay, see this. So can I calculate the ultimate BOD of stream A? Because see, BOD 5 is given. that is nothing but BOD ultimate into 1 minus e to the power minus, and see, this is your base 10, so I will use here not e to the power, I will use here minus 10 to the power minus kd, k into t. So from here I can get ultimate BOD, that is BOD 550 divided by 1 minus 10 to the power minus k 0.115 into time, that is 5. So the ultimate BOD comes out as 8.13 milligram per liter. Now see another thing, and because the temperature was 20 degrees Celsius and K value is also given on 20 degrees Celsius, there was no issue. But now what we are going to do is that let's calculate the K value at temperature 10 degrees Celsius. That is nothing but they have given the temperature coefficient also 1.135. So let's put that. So K10 is equal to K20 1.135 to the power T minus 20. So K20 value is 0.115 into 1.135 to the value 10 minus 20. So it comes out to be 0.0324 K10. Okay, now we have K10. And one more thing, the ultimate BOD remains same. It is irrespective of temperature. Okay, so hence we can say the ultimate BOD will always be this 68.13 milligram per liter. So if I want to calculate the for stream C the 5 days BOD, now 5 days BOD for stream C, so I can say BOD 5 for stream C is 68.13 into 1 minus 10 to the power minus 0.0324 into time 5 comes out, the answer comes out to be 21.21 milligram per liter. So it is NET, that is 21.21. Up to 1 decimal place they are asking. Okay, 21 point. Let's do question number 6, which is a wastewater stream flow 2 meter cube per second, ultimate BOD 90 milligram per liter, is joining a small river flow 12 meter cube per second, ultimate BOD 5 milligram per liter. Both water streams get mixed up instantaneously. Cross-sectional area at the river is 50 meters square. Assuming the deoxygenation constant K 0.25 per day, BOD of the river 10 km downstream. Okay, let's calculate. See, we have given discharge of the sewage water, a wastewater, is 2 meter cube per second, and BOD of sewage water is 90 milligram per liter, and discharge of river is 12 meter cube per second, and BOD of river is 5 milligram per liter. Both the BODs are ultimate BODs. And then they have given the area 50 meters square and the deoxygenation rate constant 0.25 per day. Next, and the thing that they want to know that 10 kilometer downstream what will be the BOD. Now can I know the BOD of mix? Yes, that will be QS BOD at S plus QR BOD at R divided by QS plus QR. Okay, so QS is 2, BOD is 90, plus QR is 12, BOD is 5, divided by 2 plus 12. So the value comes out to be BOD of mix is 7.14 milligram per liter. Now we have BOD of the mix. Can we calculate? See, we know that velocity is equal to discharge upon area. Yep. So the total discharge is 12 plus 2. Total discharge is 12 plus 2. So 2 plus 12 divided by total area of the river is 50 meters square. 50. So the value comes out 0.28 meter cube. So the velocity comes out to be 0.28 meter per second. Okay. Now the time taken. Can I calculate the time? Yes, time. How can I calculate? Time is nothing but distance upon velocity, and distance they were 10,000 kilometers divided by velocity is 0.28. So the value comes out to be the time 35714.28 seconds. And if we change it into days, it is 0.41 days. Now the BOD remaining is LT, that is L naught e to the power minus KT. L naught is BOD of the mix. The value comes out to be, BOD value is 17.14. So the BOD mix value comes out to be 17.14 into e to the power minus 0.25 into 0.41. So the value is 15.46 milligram per liter. So the correct option is option. Let's move on to next question, which is, in a certain situation, wastewater discharged into a river mixes with river water instantaneously and completely. Following is the data available: wastewater DO, discharge rate, river water DO, flow rate of the river water, temperature 20 degrees Celsius, initial amount of the DO in the mixture of the waste and river shall be. So the DO of mix we need to calculate. So DO of mix is equal to DO of river into discharge of river plus DO of your wastewater into discharge of wastewater divided by QR plus QS. DO of river is 8.3, discharge is 8.7, plus DO of sewage is 2, discharge is 1.10, and total discharge is 8.3 plus 2. So the DO of mix comes out to be, this is not that. See, we have to put the discharge values, right? Discharge rate of the wastewater is this, and discharge rate of river water is this. So QR is 8.7 plus QS is 1.1. So the value comes out to be 7.59, which is approximately equal to 7.6, and the correct option is option C. Next is question number 8, which is match list 1, characteristics of sewage discharge into the inland water and allowable limits. Select the correct answer using the codes given below. So I will directly write what is the permissible limit. So for BOD 5, the permissible limit is 20 milligram per liter, and COD, the permissible limit is 250 milligram per liter. Oil and grease, the permissible limit is 10 milligram per liter, and total suspended solids is 30. So BOD 5 is 20, COD is 250,
So 3 1, and oil grease is 10, and total suspended solid is 30. 3 1 4 2. Option C is the correct option.